All right, so when you want to set up a network monitoring system, there are some considerations. Now, if you have a company that is setting up monitoring before they're in trouble, that's wonderful, but very rare. Almost all security improvements at companies happen after they get hacked. That's what motivates people. So if you're like Mandia and they've called you as a consultant because they got hacked, then they obviously don't have a monitoring solution already there that's working, and you have to set something up. So they used to use laptops or one-use servers. They just add an extra device to the network, and then you connect it with a tap. Just a little hardware tap, like a hub, will just copy all the traffic over. And therefore, this is good because you can have it all ready to go, plug it in. All you need is power and cooling, and you can add it to the existing data center. If you, like I mentioned before, if you have an IDS solution, you cannot expect it to both do real-time alerts and do capturing entire packets. No piece of hardware can realistically do both of those things. You need two separate devices doing those two things. So, like everything else, I really appreciate this because I did analysis of various kinds of attacks and intrusions, and I found it to be very painful with the old-fashioned criminal-based forensic work because you have too much data and you spend too much time digging through piles of data. This is the real message of the incident response. Don't collect everything you can collect. Target your information to get what you need to be efficient. Otherwise, you will just waste your time forever. And so you have to first define why you want network surveillance. What is it you're going to stop? This is another thing people often don't think about. They say, I want a secure system. They say, well, don't tell me that. You have to tell me what you want. You have to say, what is your threat model? What are you trying to stop? Because you can't stop everything. So you have to define what are you worried about. And then think about it and figure out a way to block that and accept that there are other things that you are not controlling. So anyway, that's the game here. Make sure you have the right legal standing. You may not be legally permitted to snoop on people's traffic. That's a big deal at UC Berkeley. I was informing them about some servers that were compromised, and they said, yeah, I know, we can't do anything because it's where the free speech movement started and the privacy of students is paramount. So they say, we can't even collect files from a server to see if it is infected with malware without getting a written document saying that every single person who could potentially use that server has consented to the search. So they say there's lots of rotten things going on the network, and we just can't do anything about it because their number one concern is the privacy of the people. And anyway, so at companies, at for-profit companies, that's typically not a problem. Anything on the company network is company property, and everybody knows that. But when people start bringing in devices from home, and if you start letting them do games and social networking at work, you increasingly mingle things that is company property with things that aren't company property, and these issues become more problematic. Yeah?
Yeah, but they're worried about the privacy, but then any other person can go on there and put on TCP dumping and totally invade everybody's privacy.
They can, and this is like what the FBI says. The FBI would also like to say that letting them snoop more would improve their privacy because then there aren't crooks stealing your credit card numbers so much. And this is the argument, and it goes, various people have different attitudes about how much they believe that argument, but I know which side they're on in Berkeley. It's very much towards not trusting the man in any form. Is the fashion in Berkeley. So anyway, so that's the game. You got to have a secure platform and put it someplace where it will catch the data you need, which is extremely difficult. If you just put it on the gateway to the internet, if there is only one gateway to the internet, then you've got some data. But what about things that happen on campus? Pac Bell. There was a famous thing at Pac Bell for like 10 years. The network administrators at Pac Bell took pirated copies of movies and music and put it on an internal server, and everybody would go to work, open their laptop, and download all this stuff. And it went on for years before the management found out. This kind of thing goes on all the time. There's very likely bad things happening on your network that don't go to the internet. So, it's quite a job to pick up enough. One thing that surprised me, you do need high-powered hardware, which is not surprising with fast processors. And now Linux is better than FreeBSD. Almost all network devices that I know that are open source are based on FreeBSD. That's been the standard for a long time. But apparently there's an issue inside the kernel, and you have to know more about Linux than me to understand this fully, but apparently the Linux default socket is something called AF packet, and that has been shown to be too slow to really capture all the traffic. And Linux now has an optional thing you can add called PF ring in the kernel, which is a faster DIC software. And so now they recommend using Linux that has that, and in particular using Security Onion, which is a special distribution of Linux just for this purpose. So if you plan ahead and you're not responding in an emergency to an attack, then you might want to buy a commercial solution you can integrate in your infrastructure and have all those pretty screens and stuff. So Solar Network sells a device and RSA sells a device. You could add a box to your network to do monitoring, and send alerts and have pretty displays of the network flow. Yeah.
So if you were going to build one for yourself, you just get your server, and then you said you could put on Security Onion and then maybe Snort or something?
Yes, and Security Onion has all the tools. Like Kali has all the pen testing tools. Security Onion has all the network monitoring tools. And it has the right extensions to run fast. It's the modified Linux to have the right network. Yeah?
What about software version like a pen test box?
Well, a pen test box will probably not be optimized for this purpose. I mean, you could do it. It'd be better than nothing, but you get better performance if you use a special distribution aimed particularly at network monitoring. So that's Security Onion. It's free. You download it here, and it comes with a bunch of analysis tools that will draw pretty graphs and rate things out. That's just showing the long tail of DNS, and a lot of these are obviously malware DNSs. Let me blow them up here. You can see these are nonsense names. The first one is, so that's a malware type DNS. And there was a fun blog a couple of weeks ago I saw where a guy wrote, I think, Python scripts to measure the entropy of names. And these malware generated random names have an entropy of 8, but normal file names have an entropy of 6. And you really don't need a large sample to spot them. These random names are easy for us to spot, and they're not that hard for computers to spot either. And that's pretty much a clue of malware if people using domain names that don't make any sense. So you got to figure out where you want to put your sensor and how the traffic is routed on your network, and see if there are choke points, one place where all the traffic goes through. If there aren't, you're going to need to sprawl sensors all over the place. And you have to consider network address translation, which is really annoying. So you do not have a source address that you can understand. You're going to have to also store some kind of a translation table to figure out what things really are. You may find it is better to just make major network changes for the surveillance. And typically after people have been hacked, they're in the mood to make a change. So you might be able to push through a change. And you talked about one company where they had a dozen locations, each with their own internet service and their own internet provider. And because of this, they said, knock it off. We're going to have one gateway to the internet and implement MPLS the same way internet service providers do, that takes all the traffic from your site and tunnels it to the main office, which goes to the internet. So there's one path out for the whole company so we can monitor it. And that's the kind of big change that is expensive and disruptive, and management would have to be motivated by something like getting hacked to make them want to do all that. So your network sensor has to be in a locked room, just like your other network equipment. Otherwise, people can mess with it, and you have to keep it up to date and have proper credential requirements on it so that people can't get in, document things, have logs, and put on a system so you know it hasn't been hacked, like Tripwire. Tripwire is great for this. That's why I added it to the projects in my other class. Tripwire is easy to set up, and you set it up to run on some timetable, like every day or every hour or whatever you like, and it just takes the MD5 hash of all the files that you specify on the box and compares them to a record of what they were last time. So it knows whether anybody has been changing any of those files. And that is really nice. That's the number one tool I use to detect my servers getting hacked all the time. I got servers that are up there to get hacked, and people keep hacking them more than I want them to. And I found that collecting whole packet data was useless because it was just a pile of junk I didn't have time to go through, and it was encrypted too. But Tripwire is awesome. It has a number I can just see how many files have been changed. And I see a 9, those are the ones I changed. If I get hacked, that number will go up to 20, and it'll tell me exactly which files got changed. So I totally know what happened and when it happened. It's really nice. It's just the kind of targeted stuff we're talking about, where instead of burdening me with a mountain of junk I can't handle, it tells me what happened in a clear way where I can easily see what I need to do about it. Anyway, so here's the point. Make sure you're actually getting the traffic you want to monitor, so you ought to test it. You ought to put in another rule to detect an innocent thing like a URL, and then go try putting it in various places in the company to see if it's really picking it up, because it's actually very hard to know how the traffic flows in a big complicated network, especially since your network documentation is probably not accurate. So you really ought to test it. Go do the bad thing or a fake bad thing and make sure you really are picking it up, or you're very likely going to find out you're wasting your time and money monitoring traffic and not getting the traffic that's important. It reminds me of another thing that a lot of people do. A lot of people set up backup solutions and they don't test them. And then a year later, they find all the backup tapes have been blank all this time and nobody did it. You have to really test these things, or they're not going to be there when you need them. So general principles, to analyze the data, Wireshark is usually all you need. Wireshark is wonderful. Wireshark does have limitations. It gets slow when the files get too big. If you want to use Wireshark efficiently, you want to cut the files into chunks. Keep it 100 megabytes or smaller in most of the machines I use. And use targeted queries in Wireshark to zero in on the data. When I first used Wireshark, I would just look at packets one by one, and you get over that. You learn how to use the filtering functions to zero in on what you want. It's much better. And I'll show you a few of these. So here's a few scenarios. This guy, so an investigation starts on December 3rd. Somebody noticed something wrong, and they went to find that this desktop system was attacked, and they ran RAR and FTP once each. And you have the complete packet capture because the company logs packet captures for 3 days. And you come in 2 days after the incident, so you still have the data, which is very common, that you have some kind of rolling log. So you have to respond pretty quickly to an incident because you're not willing to pay to store the data too far back. So you look at the Prefetch folder, like you're doing in the projects, that will tell you exactly when people have been launching these things, so you can see exactly when FTP was executed. And you interview people and find out they do not normally use command line FTP or command line R on the machines, which is typical. Most people wouldn't. So that's pretty much the bad guy. So you have a PCAP file. You got 73 FTP sessions on that date, and there are 2 that are active during the time of interest. And there's PCAP files here. So let's take a look at them. These are good fun. You can download them from the textbook. I could use them for homework. I'm not sure it's that interesting, but it might be. Anyway, here's the Chapter 9 Scenario 1 PCAPs. Here's 2 PCAPs. So all you do is open these things in Wireshark. These are the PCAPs of interest. So this one's really quite small, only about 30 packets. Now, like I say, when I was a beginner with Wireshark, I would try to read this thing one by one. You've got times, you've got source and destination addresses. Over here, you've got the protocol, and you have a summary of the packet. So this is SYN/ACK to connect to port 21. Then this is a prompt from the server saying I'm an FTP. Then this guy logs in with the username of Frank and a password of Frank, and login successful. You're seeing all this happen. Okay, that is how you use Wireshark when you don't know how to use Wireshark. The cool way to use Wireshark is this. You do conversations list is a very good way to start. Statistics, yeah. Conversations. This will summarize the entire traffic in a very simple chart. It'll tell me I have 2 Ethernet flows, 2 IPv4 flows, and 2 TCP flows, and a UDP. So TCP is the one of interest, and right here it tells me I went from this address and that port to that address and that port. This is 21 and 20, which is what FTP uses. 21 is the control port, which is used to send commands, and 20 is how the data flows. So you can, and it tells you how many packets and how many bytes were in each of these. So it sent 955 bytes of commands and moved 1,646 bytes of file transferred. And then you click one of these and follow the stream. This is awesome because it gets rid of all the addressing and just shows you what appeared on the screen. So you can just see what's going on without any complexity at all. This blue is what the server said, red is what the user said. So this guy logged in, switched to binary mode, and transferred some file called eddytransfer.bin. That's it. Very simple. And if I want that file, this is what's even better. I select the other stream and follow it. Okay, that's the stream. Now this is a RAR file, but what you're seeing here is the ASCII text printed, and the reason all those dots are there, those are the non-ASCII characters. So this is slightly useful, but for anything like a compressed file or a binary file, you don't see much you can read, except often at the start of a file they'll have a header that you can read, like in a JPEG. But this is not the most practical thing. Though, since you have a reason to believe this is a RAR file, a common kind of archive, you can take the file right out of Wireshark. You have to show the data in RAW, and that will show you hexadecimal values, and then you just save the file. Save as. And I'll put it in downloads and call it demo1.rar. Demo21, that's fine too. Okay, so now I've created a RAR file, and that's it. And now if you want to analyze a RAR file, the Mac free tools to do that are not much good, so I prefer to use Windows, and we're going to need Windows anyway pretty soon. So let's get Windows up. All right. And bring in that RAR file, which is here, demo1.rar in downloads. There it is, demo21. All right, so I put it in here, and I installed WinRAR on this thing. So there it is, demo21.rar. Right-click. I said right-click, thank you. Open in WinRAR, and WinRAR will show you what's in that file. So what's in there is a thing called cache dump, PW dump, and then some other things. And by the way, if you try to extract these files, it'll ask for a password, which I don't have. And in this scenario, we never do get the password. But this is true of RAR files and also of zip files. If you password protect them, no one can unzip it, but they can still see the names of the files. And this is very much like that header information where you may not really need to know the contents of the files. The names of the files might be enough to answer your question. And in this case it is, because this is a well-known hacking tool. PWDump is one of the most common hacking tools. This is how you steal password hashes from a system. So the attacker transferred up something and then transferred back information from PWDump. So apparently he was stealing password hashes from the system. Yeah?
Is there a way to crack our passwords?
There is. There are cracking tools, and all they do is go through a long dictionary and try. So you could try that if you want to. Another thing, like they say, is if you could get a memory image of the machine or a hard disk image, you could go through the command line commands. You did that with, I think, Bulk Extractor, or one of these tools. You got to reconstruct the command line commands, and you could see if they typed the password in somewhere. There are ways to hunt for the password if you need to. Yeah?
So the hacker puts up this RAR file with all these hacking tools in it, and then at some later point he must have extracted it and used
Well,
it.
he put up somehow he hacked in the machine, and what he did was run this file to steal the passwords, and then he chose to send it back to himself as a password-protected RAR file, which is the kind of thing you often do. Like, for example, you notice I have several password-protected 7-zip files on my server because my hosting provider will detect malware on the server, and the networks will detect malware on the server, so I encrypt it with a password. And by the way, if you want to mail viruses around, so like researchers, the standard is you 7-zip them with the password malware. That's the standard, but that's enough that no antivirus engine will catch it, which is kind of stupid, but that's the way it is. Encryption is sort of the open door. So anyway, this is the evidence that this guy was stealing passwords off the machine, and that's the first session. Let's take a look at the second session, and the same techniques work very well. There were 2 sessions. I want to go to here. All right, I'll open a new one. There we are. Go to my downloads. And this one, okay, scenario 1, part 2. So here's the second one. This is old information. There it is. Let's clear this. All right, this one is much bigger. 500 packets. And again, you could look at the packets one by one, but that's for the birds. So use statistics, conversations. And again, there's 2 sessions of TCP, which really are one action done on the 2 ports, port 21 and 20. Here you have 1,700 bytes of commands and 608 kilobytes of data sent. So again, you can see what happened by just viewing the commands. So this guy logs in as Frank again, and he moves this thing called eddysource.bin. That must be that big file. So that's nothing too exciting. And this is follow stream. This is a big blob of data. Again, it's a RAR. Oops, I gotta hit the right button. It's a RAR again, and it's really big, so you don't even need to worry about it. Just go to raw and save it with something down here like stream2.rar. Oh, that's fine. Whoops. Save as. Downloads. Okay. Stream2.rar. All right. The real file ended in bin, but it happens to be a RAR, so I might as well give it the right extension to make my life easier. And now I can take that file, which is here, stick it in any place to analyze it. I'll use Windows, so I have glorious WinRAR. And this WinRAR shows the information that was stolen. The names of the files, the name of the folders. Again, I don't have the password, and I can't open it, but I know the names of things that were moved, and that may be enough to answer the all-important question. And what's even more fun, I think we're coming up to that one a little later, is the next one. So let's get this back up, which is here, and see if there's anything in these slides that I neglected to mention. So you can, here's what you do in Wireshark: statistics, conversation, select the conversation, and follow stream is how you get these lovely layer 7 printouts that show you just what you need to see without confusing you with a bunch of irritating nonsense like MAC addresses or something that you don't care about at this point. And you can just totally reconstruct the file. So there's the second file. All right, so these are password protected, and there are ways, by the way, one common trick if you want to break a password and you have an evidence machine from the attacker is you just take every word on the hard drive. Dump the whole hard drive to an image, run strings on it, you'll get about 1 million words, put it in a dictionary, you X out your dictionary. If you're lucky, they put the password somewhere in some file. Anyway, all right. So now another question you might have is, was this an automatic process? Was this malware all done automatically, or was there a human in the loop? And you can tell from the TCP, from Wireshark quite easily, because there's 2 ways to do it. One is to look for the commands here that were typed in, like user Frank and password Frank, and see if at some point they made a typo and had to do the command again. The other thing is just look at the timing. You can see on the left here, and I think I'll make this as big as I can. Okay, this is the prompt. The prompt comes in at 0.003 seconds. Then the user logs in at 2.5 seconds. So they had to look at the screen for 2.5 seconds before logging in. This is a human. This is not an automated process. It would have answered in a fraction of a second. And again, they put in the username, then it says, give me the password, and again, there's a gap from asks at 2.5, and the password's not in there until 3.9. This is a human. Yeah?
But can't these automated things configure themselves?
They can.
Pause for 2 seconds.
They can, and that's true of everything. Everything we do is only assuming the attacker isn't onto us too much. So all you ever do is get the dumb ones. The same thing like catching cheaters in class. The smart cheaters, you'll never catch them. The dumb ones you catch. And it's true of all criminals. All your security barriers only stop attackers to a certain level, and that's why you have to start with threat modeling. You have to decide who you're afraid of, and that's why there's just like there's a sucker born every minute and a crook to exploit them. There's a bunch of people selling you products now to stop the NSA from snooping on you, and this is just ridiculous. There is nothing you can get in heaven or earth that will stop the NSA snooping on you, no matter how much money you spend. So if anybody is selling you a product on that basis, they are hoping that you're a fool. Anyway, and that's why you have to have a reasonable threat model. Who are you really afraid of that you think you could reasonably stop? And it's not the NSA. Anyway, but all right. So there you get your files. You saw these. All right, and the other one's even more fun. So this is a web shell. Somebody detects a port scan coming from inside the company, from inside the DMV. It's port scanning the rest of the network from an Apache server. Well, that's not right. That's not authorized activity, of course. Nobody should be doing that. And on top of that, none of our administrators were even logged into the server at that time, so somebody else is gaining control of our server and using it to scan the network, which is very common. If you take the hacking classes, this is a very common kill chain. You go for the public server, like the web server, the DNS server, the email server, you compromise it, then you're inside the network. You put hacking tools and scan again from there to pivot, because typically the goodies cannot be seen from the outside, they can only be seen from the inside. So you go on one machine, scan, take over another machine, and you do hop, hop, hop from machine to machine to get into the network. So looks at the Apache server logs and sees a large number of requests at the time of interest from an external IP address. First, many different pages are loaded, and then there are many requests of the login page. This is something an automated scanner might well do, a vulnerability scanner. It'll try a bunch of pages. When it finds a login page, it'll then try a bunch of passwords on the login page. And then, after many post requests to the login page, then there's a lot of get requests to a PHP page, including commands. And this is a PHP shell. This is great fun. We do this quite a bit. And what's fun is this one. Let's play with this one. If I go to Wireshark here, and I open up the packet for this scenario 2, which should be someplace here. There, scenario 2. Okay. It might actually decrypt this, which will be annoying. Let's see what happens. Okay. And get rid of this. There we are. All right. Yeah, this is messed up. All right, I'm going to have to, I decrypted earlier today, and I'm going to have to start with it encrypted. So let me go through my slides to find out how to get rid of this. I'll just use my slide. All right, when you first open this thing, what you see is SYN/SYN-ACK on port 443, followed by client key exchange and change cyberspace. This is an HTTPS session opening. HTTPS first opens the TCP port, and then it sends certificate information and key information back and forth in a 7-way handshake. So if this is real HTTPS, then we got a problem, because you can't see any of the data. All you see is scrambled stuff. Now, there are ways to get in, but they're pretty nasty. However, we control the server. We're working for the company. So if you are using TLS 1.0, I think that's the version that does not have perfect forward secrecy. Forward secrecy is now popular entirely due to the NSA and Snowden. After people found out the NSA was snooping on everything, they all freaked out, and the NSA has an attack, which they're definitely implementing, which is record all the traffic and store it forever in this place in Utah, a giant data center, because if you get the key 5 years from now, you can go back and decrypt all the old data. That works because you don't have what's called forward secrecy. And TLS 1.2 and I think 1.1, I'm not sure, has perfect forward secrecy, so every session has a separate key, and there is no master key. That's a desirable property of crypto systems. In this case, they're using an older version of TLS, so all the encrypted traffic has the same key, and the private key is on the server, and you can get it. So they gave you the private key in a file called server.key, and you can import it in with Wireshark. You just go Wireshark Preferences, SSL, and then you can import the key here. You tell it the IP address and the port and the key file. They give a file called server.key. And then after you do it, Wireshark knows the key and it will automatically decrypt anything it can decrypt with that key, which is really handy. So that's where I am right now. I've already imported the key into my Wireshark. So what's happening is this HTTPS traffic has been downgraded to HTTP and I can see it. Now, what's even more fun is if you want to see this traffic, there is a feature which is not in your book because I added it to Wireshark too late, but I've looked it up in the Wireshark forums, and this was pretty cool. You can now export just the high-level data. You do File, Export PDUs. PDUs are Protocol Data Units. So I can export higher-level units. I can export just the Layer 7 data. This is the analog of that follow stream thing I did for the FTP, where I see just the good stuff with all the confusing stuff removed. So you can hit OK here, and then you get just the HTTP requests with none of the nonsense. And now you don't even have to look at the packets. You can just see what's happening here. Post login, post login, post login, post login. If you look inside one of these, you'll see down here that it is filling out a form, and it's filling it in with junk like 2 dot parentheses, dot parentheses. This is what vulnerability scanners do. They try a bunch of malformed things full of punctuation marks looking for SQL injection and cross-site scripting and errors like that. And not only that, if you go up into the HTTP headers up here, you'll see that this product has a, come on. All right, there we are. It has a user agent of SQL map. This is a well-known hacking tool. We use it in the hacking class. It's a Linux-based tool that finds SQL injection. So this entire network trace is an automated scanner trying to find vulnerabilities on my website. And from what came later, apparently they found a vulnerability and exploited it. And that's in the next one. So let's go to the next one, which is even more fun. So we go here. You open it up. I've already imported the key, so it'll automatically decrypt all this stuff so I can see the layer 7. Here's one of these logins again. Well, the cool way to get rid of that is to export just the layer 7 data. So File, Export PDUs, and I just want layer 7. Nothing else matters to me right now. And now I've got this stuff. Okay, so it's posting logins. Then at some point, it finished that, and it started posting to some other page. Now what happens is when it's done posting logins, he uploaded this file called tempbkxcn.php. And if you use PHP shells, which we use them in the hacking class and the advanced hacking class because they're great fun, you get used to the way, this is the way it looks. You send a get to a PHP file with a command there, and these are Windows DOS commands. So he just did echo command execution test, then he does unzip nmap, run nmap, then he does network commands, text, runs a batch file, task list. These are all the commands he did to survey the network from here. He put up nmap, unzipped it, ran nmap, ran this batch file and other things. And then here, he did some netstat commands, and this is net user. This is how you create a new user on a Windows system in the command line. This creates a user with a name of backup and a password of secret. And this adds that user to the local administrators. So after this, he has his own backdoor secret administrator account, which you wouldn't know. And it's so easy to see here. You don't need to export it or decrypt it or anything. And then he does other things here. So that's pretty good. You can now reconstruct what happened. They found a SQL injection with SQL map. They exploited it to put up a PHP skill, used that to make an administrator account, and put up nmap, and then scan for further things. So, that's a whole lot better than doing something like spending hours collecting a hard drive image and then a week analyzing it. You've quickly found out what happened. And that's the goal here. All right. So that's the game. And we talked about all these things. Yeah, there's the commands and the ones in the middle that make the user. All right, there's another product you can get called NetWitness Investigator. It used to have a free version that ran on 32-bit machines, and I even used it in this class a few years ago, but the 32-bit version seems to be gone. It's still around. It's another tool that does a similar thing. It will sort out traffic by protocol. So you get all these blue links, like, let me make this bigger. You'll see HTTP, other, SSL, NetBIOS. If you click on this, it'll show you the streams. It's sort of doing what Wireshark does with that conversation list, but it does it for a whole packet and sorts into all these categories, shows you the host names people have been going to, and if you click any of these links, it'll then take you to the PCAPs. So you can see what happened there. Anyway, it's another tool available out there. Some people like it. So another thing you can do is you can collect logs from your events. All your devices are keeping logs, your routers, your firewalls, your DHCP servers, all your sensors are collecting all these logs. And the problem with these logs is you're typically on the hard drive of a system somewhere, like a server. and you have to accumulate them in some general place. So also, things that are stored on a system are likely to be altered by the attacker. We just saw that attacker with the PHP shell gain administrator access to the machine. I did not see them deleting the logs, but they certainly could have deleted the logs, and many people do. So it's an issue. So network-based logs are probably better, where you take network information and put it in. In general, in practical terms, they are considered more reliable than host-based logs, although a lot of people deploy something like Splunk and collect all the logs in one place, like have a SIEM system, so they can detect intrusions. But you're aware that the logs you got from servers are less reliable than the logs you got from the raw network packets, because it's hard for the attacker to conceal the network packets. Anyway, you aggregate your logs as much as you can, and Splunk is one good product for this. It is really a pain, but the reason they've modeled it after Google, because Google has the same problem. There's a billion websites, and there's nothing uniform about them. There's no format, there's no header, there's no summary, so you have to deal with unorganized data, and that's what logs are. Every log format is different, so you just dump it all somewhere, and you can still search for things like IP addresses that should be in there somewhere. And that's the issue. And Splunk has a whole bunch of collectors you can install on all different systems that will collect whatever data is there and send it back to the main server in some more or less rationalized format. Anyway, I got a few more eye clickers about this. And I want to talk to you about a couple projects. And I've added a couple new projects. All right. So, which one of these could do intrusion detection or surveillance, but not both? Quit at 30. All right, and that's IDS systems. One or the other, but not both. All right, now the very popular answer. All right, what's the best OS for network surveillance? May I quit at 25? Looks like the answers are in. All right, and it's Linux now. Used to be Unix, but now it's Linux.
You said security onion.
What's that?
I said security onion.
That's not an option.
There's something else.
But Security Onion is Linux. It's not Unix. It used to be all those things were like Viata is OpenBSD, and so is a lot of those router type things are all based on OpenBSD, which was considered the best. But now it's Linux. That's what they say, which is news to me. Linux has come of age. It used to be anything serious had to be Unix. Anyway, all right. Which one keeps your operating system files intact?
Intact? What is intact?
Intact means unchanged, have not been tampered with. Integrity. All right, I'll quit at 30. All right, and that's Tripwire. Tripwire informs you of all the changes, so you know, and therefore you can look at the Tripwire report, and if it hasn't changed, you know that nothing has been changed on your server. So it's an integrity tool.
Is it a paid service?
No, it's free. There's a paid version, the Windows for fancy stuff, but the free version on Linux has been free forever. It's very simple. Yeah.
Does that prevent change?
It's a control. It does if used properly. And the right way to use it is when it changes, you know something has happened. And that's the same is true of IDSs. They don't actually prevent something, they mean you know about it. So it's used to prevent it. I know, I worried about that, but people will say that it's a control. A control that monitors something is still part of how you prevent it. But you're right, you could argue that. Maybe it would have been better if I used a different word there. Like detect changes. Anyway, so what's the file format used by hackers to execute commands on a server? I'll quit at 30. All right, and that's PHP. PHP shells are the cat's meow. I learned about it from a guy hacking my server. And I said, how did you do that? And he showed me his PHP shell. After that, it's not one of my favorite tools, but I learned about it by getting hacked. Anyway, so, all right. Let me just point out a few projects. There are some new ones, and I'm pretty pleased with the way this turned out. So, there's a 5 in Prefetch, which is good. It's not too difficult. You just have to do a few registry hacks to make the Prefetch folder appear on this. And I made it so it's not due for a couple of weeks. So it's not due until October something. So the projects are a little bit out of order. I delayed project 4 by a week because a bunch of people were getting stuck on the hashes. A lot of people, your image will not produce the hashes. So if that happens, go here and get my image. You'll be able to get the hashes out of my image. That's why I put this here, memdump.7z. If you use mine, the hashes will appear. A lot of students are finding theirs, it won't appear. And I don't know why that is. I'm blaming it on a bug in volatility, but I really don't know. If anybody figures out why, you'll get extra credit. Anyway, then I finally got project 15 up. It's been waiting a long time. This is the one most relevant to this chapter, Mandia Redline. I've been using the Mandia Redline for about 2 weeks trying to make it work, and this product is very disappointing. I thought it was going to be awesome, and in fact it is extremely ineffective. However, you ought to know how to use it. So, because it does let you see what live response is. So the right way to do this is to have 2 computers. One that you trust, which is your analysis machine, and you go to this machine, install Mandia Redline, and create a collector. You put it on a USB stick, then you put the USB stick on the evidence machine and run the collector, and it puts the evidence on the USB stick, and that's all you do on that machine. Bring it back to your other machine and run it. That's what you're supposed to do. Now, there was no point bothering with all that, and it turned out to make it much faster not to use the USB stick. So we're just going to use the same machine for both roles, which is sleazy and unprofessional, but at least you get to learn how to use the tool. And after experience with the tool, I'm a whole lot less happy with it. So you download Redline, which is free, put it on your machine, and then once you've got it, it looks like this. So you can create a collector. A comprehensive collector is the thing to make. I tried all the others. The comprehensive collector without a memory image. This would get a memory image. Just don't bother with one because you don't need it. And it's probably the most valuable thing. You can go through and see what it collects. It lists the processes with all the information you would find in Microsoft's Task Manager and ports, and it looks at all the drivers and hooks. Hooks, we talked about in malware analysis class, are ways to make one software product detect another, like a keylogger. Hooks the key press mechanism, so when you press a key, the keylogger gets told about it, and it also can be used to restart things, and it tells you exactly what it gets on the disk. It's probably the most valuable thing is go through and see all the things it's collecting. It's a carefully selected group of logs and things, and then you run it. Okay, so you create your script, put it in, make a folder and put it in there. You'll end up with a folder with your collector package. And then you're supposed to take it to another machine, but I would leave it in the same machine. You just run Redline audit file. And that will run a batch file, which will appear in a command prompt, and it will now scream across the screen with error messages. Just like if you ever use anything in Linux, you get used to this. And Microsoft, everything booting up always does this, and around Windows 2000, Microsoft figured out the users don't like to see a bunch of error messages going across the screen, so they started putting a pretty logo up there instead, but the error messages are still behind there, and you can turn them back on if you want to see them. So this will now take about a half hour of junk running, mostly complaining about things it can't find. And when it's done, it will save a whole bunch of files in that folder, which are all the little log kind of things it collected. And the other thing really baffled me, you need to analyze live response data. And remember, the whole point of this class is that you don't collect the whole disk and the whole RAM, you collect just the right targeted stuff. And yet, Mandia used to have the option to collect live data right here, and they hid it. I thought I'd have to go find an old version of the thing. They hid it under this, which is kind of nuts, which makes me think that maybe they're losing faith in their own tool. The only option here is to get a save memory file, which is the whole RAM dump. But if you don't want to use the whole RAM dump, you go up to that little square, which isn't even obviously clickable, and in there is analyze collected data. And so you can run an audit on the collected data. You just have to browse to it, and then you have to make a file to put the answer in, and this only takes about 3 minutes. It analyzes that data, and what it does is after it does this for about 3 minutes, here's the result, and now you choose what you're doing. A triage collection for HX, whatever that is, host based on an external lead. This is the one. I'm reviewing a full live response or memory image. You click that, and what it does, which sounds great, is it's going to put it all here so you can log through it. This is your processes, your registry, your file system, and it's going to take all the processes and it's going to rate their malware risk index score using some kind of heuristic technique to decide how malicious they are, which sounds swell, but it totally doesn't work. So this thing here shows a bunch of processes and none of them are malicious. They're not red. There's an MRI score over here of 61 or something, and the higher this score is, the more malicious it is, but none of these are particularly malicious. And I put a whole bunch of malware on my machines. I got downloaded fake malware for practical malware analysis. I ran Metasploit and made a bunch of malware, and it didn't detect anything. And I was pretty disgusted. And then I found a video from some guy that says the way to make it work is you have to open a Metasploit shell and put on a keylogger and start actively logging the keystrokes while it's running, and that is horrible enough that it will actually detect it. So when you do yours, it probably won't detect anything bad. So get this far, and then I said download mine. I saved mine up on the, and this is why you can see the advantage of it. It's only like 30 megs. It's not too much data. This is my audit of my machine that was under attack. And when you analyze that one the same way, it will finally actually notice that something is wrong with it. This is the file that's been hacked. This is an innocent file just being flagged in error. Like I say, this thing is pretty annoying. But anyway, FTP Basic Server is in fact the thing that's been exploited. And if you double click it, you can get the malware MRI report that shows you what are these negative factors, and it tells you something else has been injected into the code. It doesn't tell you any information about it, which is perhaps annoying, but these injected things means it did find hooks injecting code in, and this is an attack that works by DIL injection. So anyway, it does sometimes detect malware, but it's not a terribly impressive product. But I think the point is you use it with your custom indicators for your targeted things. That's what it's really designed for. And I think that's it. Let me see if there was something else new down here. I put this thumb cache project back in, which I think I showed you last time, I don't remember. You make an image, and the point of Windows is snooping on you all the time. So what happens is you make an image, you view it, and then you just throw it away in the trash bin and empty the trash bin. And there is still a thumbnail of that image preserved. That's called the thumb cache, because in order to display thumbnails in Windows Explorer, which you see here, when you open this thing, Windows Explorer, it has this little thumbnail of it down in the corner. In order to create that, it has to make these thumbnails, and it doesn't remember to delete them when you delete the image. So if you think someone has been looking at the forbidden image, you can totally find it in the thumbnail cache, but you need a special tool called the Thumb Cache Viewer to open these files and find them. So it's a fun thing to know, and that's all this project does. Another kind of evidence people go for. All right. So I'm going to stop this thing from recording. I'll see who won the iClickers, and then I'll go to the lab to help anybody who wants help. 121, chapter 9B.